What if I told you that our solar system could be rearranged like a line of contest winners, not by how far they are from the sun, but by how big they really are? Our journey begins with a twist on the classic space story. In this video, we explore a wild concept. What if the planets were ordered strictly by size? Right now, we think of them in terms of their orbits and distances. But what if we lined them up from the smallest to the largest, creating a cosmic scale that would leave us all in awe and a little confused about how things really work? Our solar system is full of surprises, and today we dive into a puzzle that mixes astronomy, physics, and a hint of humor. The idea might seem simple at first, but as we look closer, a universe of questions unfolds. Let's start by getting a feel for our planetary cast. We all know Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But did you know that each one has a unique size that could change how we see them if we put them side by side in a neat line? For example, Mercury, the smallest planet, could be seen as the baby of the solar system, while Jupiter, with a diameter of about 86,881 miles, towers over its siblings like a gentle giant in a playground full of cosmic wonders. Now, if you think about it, our solar system is more than just a random collection of rocks and gas. It's a carefully choreographed dance of objects that follow their own secret rules. When we rearrange them by size, we begin to see a new order emerge that sparks questions about gravity, formation, and the very history of our space neighborhood. The twist here is not just about rearranging numbers on a page. There is a challenge that comes with this thought experiment. You see, our planets did not form in a neat sequence, and their sizes come with a lot of baggage. Some of them are made of gas, while others are rocky. Some spin quickly, while others drift lazily through space. What happens when you line up rocky worlds with enormous gas giants? What if the small ones, like Mercury and Mars, suddenly had to share the spotlight with giants like Jupiter and Saturn, which are so massive that their gravitational pull could affect the others? This thought experiment forces us to rethink everything we know about how planets interact with one another and the balance required to keep them in orbit. It's a cosmic conundrum that leads us to ponder how our universe might look if it followed a different set of rules. A puzzle that tickles our curiosity and challenges our understanding of space. Now let's dig a little deeper. In our current view, the planets are arranged by how far they are from the sun, which creates a familiar order: rocky planets closer in and gas giants further out. But what if we reordered them purely by size? We would start with Mercury, the tiniest, and then move on to Mars, which is only slightly bigger. Earth might come next, followed by Venus, each of them with their own unique mix of land, water, and atmosphere. The real game changer appears when we hit the gas giants. Jupiter would be the undisputed champion, followed by Saturn and then Uranus and Neptune. The twist is that such an arrangement would not follow the natural progression of heat, light, and distance from the sun. Instead, it would create a display that feels almost like a cosmic art installation, a sequence that forces us to question why things are the way they are. In this reordering, we start to see how size alone might dictate new dynamics in our solar system. For instance, if the planets were arranged by size, smaller planets might be more susceptible to the gravitational influence of their larger neighbors. This means that the tiniest planets, like Mercury and Mars, might have to endure unexpected gravitational tugs from the massive gas giants. Think about it. A small planet being nudged by a giant every time it passes by, like a kid getting a playful shove on the playground. It raises an interesting question. Could these gravitational nudges alter the course of these smaller worlds over millions of years? Or even change their shapes? While our current understanding of orbits and gravity suggests stability, this scenario invites us to re-examine the delicate balances that keep everything in check. But it's not just about the push and pull of gravity. When we consider a lineup based solely on size, we start to appreciate the diversity in planetary compositions. The gas giants, with their swirling storms and layers of gases, would stand out in this ordered line, almost as if they were giants in a fairy tale, while the rocky planets would appear more modest, like humble cottages in a cosmic countryside. This contrast between different types of planets offers a fresh perspective on how the solar system might look if it was designed with a different set of priorities. It's as if nature decided to mix and match, creating a set of objects that are far from uniform, each with a story written in its size and composition. Now, consider the implications on how we understand planet formation. Scientists believe that planets form through a process where dust and gas slowly come together in a swirling disk around a new star. Over time, these materials build up, and gravity plays a key role in shaping the planets. When we arrange them by size, we highlight the end results of this process. The smallest planets represent one path of formation, and the largest represent another. It's like comparing a carefully crafted sculpture to a massive, naturally formed boulder. Each tells a different story about the conditions present during its birth, and by ordering them by size, we get a clearer look at these divergent stories. A fascinating twist in this story is the potential for discovering new rules of planetary behavior. In a universe where planets are lined up by size, one might wonder if there is a hidden pattern that we have missed by focusing only on distance from the Sun. Could there be a secret relationship between size and other characteristics, such as temperature, atmospheric composition, or even the potential for hosting life? When we start questioning these connections, our curiosity grows, and we begin to see the solar system as a collection of puzzles waiting to be solved. Each planet becomes a clue, and their sizes might unlock a new understanding of how they interact with one another. This line of inquiry might even lead to fresh ideas on how planets in other star systems are arranged, sparking debates and discussions among scientists and space enthusiasts alike. The humor in this cosmic reordering comes when we think about the planetary popularity contest that might emerge. Imagine if planets had personalities based on their sizes. Mercury could be seen as the energetic little one, trying hard to prove its worth, while Jupiter would be the charismatic heavyweight, always drawing attention with its massive presence. Saturn might be the fashionable giant, known for its iconic rings, and Uranus could be the quirky one that everyone talks about because of its unusual tilt. This lighthearted view adds a touch of whimsy to our discussion, making the complex science behind planetary formation a bit more relatable and fun. Of course, there are challenges to this reordering that cannot be ignored. The biggest dilemma is how such a lineup would affect the gravitational relationships we take for granted. The planets do not exist in isolation. They are part of a delicate gravitational ballet that has been performing for billions of years. If we rearrange them by size, the gravitational pulls might shift in unexpected ways, potentially altering orbits and even the stability of the entire system. Scientists have spent decades studying how gravity shapes the cosmos, and this thought experiment forces us to reconsider those principles. Would the small, delicate planets be able to maintain their orbits in the shadow of enormous gas giants? Or would the sheer mass of these giants disrupt the entire structure of the solar system? These questions lead us into a realm of scientific inquiry that is as thrilling as it is complex, a realm where even small changes could have big consequences. While these questions might seem purely academic, they have real implications for our understanding of space and the search for life beyond Earth. If we discover that the size of a planet plays a role in its ability to support life or maintain a stable climate, then ordering planets by size could become more than a fun exercise. It might help us identify which planets in distant star systems are worth investigating. In our solar system, Earth is the only planet known to harbor life, and its size plays a crucial role in maintaining an atmosphere and a magnetic field that protect life from harmful space radiation. By comparing Earth to other planets in a size-ordered lineup, we might uncover clues about the conditions that make a planet habitable. This pursuit of knowledge keeps us curious and drives us to explore further, not only with telescopes, but with our minds. As we bring our exploration closer to a satisfying conclusion, the cosmic ordering by size turns into a mirror reflecting our own desire to find order in chaos. The universe is vast and full of mysteries, but sometimes all it takes is a different perspective to see patterns where we once saw randomness. By considering our planets in a new light, we appreciate the intricate balance of nature and the endless possibilities that come with rethinking the familiar. In a way, this thought experiment serves as a reminder that science is not just about accepting things as they are. It's about asking daring questions and exploring the unknown with an open mind.